time to talk about arrays. So once again, this is another type of data structure. So it is another way for us to organize our data. Right off the bat, let's go ahead and initialize an array. I will say int, and this is actually how I say that I want an array of ints, right? Then I will name my array. I will say my first array. I will say new int, and then here's the kicker. I will have to give it a size, an initial capacity. So in this case, it's going to be 10. Let's go ahead and see how it looks like. I will run and breakpoint, and then let's go ahead and see how it looks like. See? There are 10 empty spots. If I was to create a list, let's see what the difference would be. So I will say list, and you already know how to make these from the previous video. And even better, I will just say var my second list equals new list that will hold integers. And then I will go ahead and run it again and go through these. Now let's see. This one has 10 spots, yet our list has 0. Why? Because, as I said, our list dynamically grows. So as we add, it just grows with that. It grows the size, it increases the size. But the array has initial capacity. So if I was to say array, my first array, 1000 equals 5, this would break. What I'm saying here is go to the 1000th index and assign 5 to it. You will see that this will break. And rightly so, because there is no 1000th index. See? This will say index out of range exception. So if I was to say 10, this would actually also break. And we will go over it in just a second as to why it would break. See? Index out of range. Why do you think it broke? Doesn't it say 10 here? Well, the reason is because if you look carefully here, it goes from 0 to 9 as opposed to going from 1 to 10. In computer science, in general, you start counting from 0. And it holds true when you're counting the capacity or the amount of elements that you can hold in an array starting from the very first position, which would be 0, going all the way up to the initial capacity. So we're saying that there can be 10 things, however we start from 0. We start counting from 0. So we say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's still 10 elements. It's just that we started counting from 0. Might be a little confusing, but just accept that that's how it works. So now if I actually went and said 9, then you would see that the very last element of the array would be equal to 5. Let's go ahead and run that. See right now, it just has 10 elements. If I do this, that turns to 5, which is the 9th indice. And this is a very beautiful thing about arrays, is that we can access them via index, meaning that we don't have to go through the entire array. We can just say, hey, even if the array has millions of indices, we can just choose a very specific one, and very performantly and efficiently, we can access that indice. The same thing can be said about lists, because lists are actually implemented based on arrays. So lists work in the following way. Whenever you add things to a list, it actually in the back end adds things to a backing array. So to us, we see that it's increasing the size dynamically. However, it's actually adding things in a backing array. And once that array runs out of elements, it just increases that array even further. And that's how the dynamic sizing works, to put very simply. So we can actually go ahead and do that. I will say add 5, and then I will say let's go ahead and access that. So I will say my second list. Let's actually print this, and I will say my second list 0. Remember, we added only one element, so the very first element would be 0. If we said 1, it would have not worked. And I can actually demonstrate it by doing it here and then getting rid of it afterwards. Let's go start from the very beginning. I will say that worked, and then we just initialize our list, instantiated our list, added 5 to it. This will break because there is no element 1, there's only element 0. See, 0 is 5. And if we actually try this out again, you will see that it will work now. So it says 5. Rightly so, because on the 0th indice is where 5 exists. So this is great. This is the difference between arrays and lists. As you have noticed that we have a capacity, an initial capacity for arrays, and arrays actually are used to make lists. But whenever you know that you only need a certain amount of variables to store, then you can use an array because it's much cleaner that way. But if you don't know how many things you're going to need to store, then use a list.